The if statement introduces a new Python data type. As you probably noticed, the result of the condition expression after the if keyword always evaluated to either true or false. True and false are known as boolean values and are named after the 19th century mathematician George Boole. The name of the data type for boolean values in Python is bool. An expression or variable of type bool has one or two possible values, true or false. These are constants in Python, and the first letter is capitalized. Note the names of types in Python are not capitalized, but constant values are capitalized. You can assign a variable to a bool constant, and you can use the exclamation point to negate the value of a boolean expression. As you should expect, not false is true, and not true is false. Occasionally you will assign a variable to hold the result of a boolean expression, and then use the expression later, but it is much more common to use the boolean expression immediately as the condition for an if statement or a while loop. We will learn about while loops soon. Functions may return a boolean value. Here is a function that takes an integer as a parameter and returns a boolean value. Beginners often write it using an if statement. Both will work, but the first version is more concise and is preferred. Since the result of the expression x% 2 equals 0 is of type bool, the function returns either true or false. Using type annotations, we would write it like this. The names of the types are int and bool, so we use those to indicate the type of the parameter and the type of the return value. The first thing to notice in this sample program is the use of this code for calling the main function. This condition will be true if we run the file, but if we import the file, the condition will evaluate to false. We will see how this is useful later, but from now on use this instead of simply calling the main function at the outermost indentation level. Here we've written a function to check if all the numbers in a list are even. This version makes a mistake that beginning programmers often make, so it is instructive to see exactly what happens. The function is supposed to return true if all the numbers in the list it has passed are even. If any of the numbers are odd, it is supposed to return false. We can then use the return value as our conditional expression in an if statement. We'll run it and see that it works correctly for the list 1, 2, 3 and the list 2, 4, 6, 8, but it doesn't work correctly for the list 2, 1, 3. We've set a breakpoint in the all-even function, so let's debug it and see what happens. When we step over the for loop the first time, x is 1. When we step over the if statement, we see that the condition is true because 1 is not even. The key thing to remember here is that as soon as you execute a return statement, the function ends, so this will return false, and we won't check any of the other items in the list. We'll step over and see that's what it does. We're back at line 10, and to complete the function call we'll press step over and see that it moves to line 13 since the function returned false. As soon as we find an odd number, we know the list doesn't contain all evens, so we can return false. We'll resume and see that now we're in the function call with the list 2, 1, 3. We'll step over and x is assigned the first value 2. We check the remainder when dividing by 2, and it is equal to 0, so the if condition is false. When we step over the if statement, it moves to line 6 because the condition was false. Now when we execute it, the function returns true, indicating that all the numbers were true. But this isn't correct because it only checked that the first number was true. We'll step over and see the wrong output. We'll resume, and with the list 2, 4, 6, 8, the same thing happens. Since 2 is even, the function returns true without checking the remaining numbers in the list. In this case, we got the correct result, but if we added an odd number anywhere other than the first item in the list, we would get the wrong answer as we did with the list 2, 1, 3. Let's see how to fix this. I've left the wrong version here so we can see it. The correct version returns false as soon as it finds an odd number. But if a number is even, it continues the for loop to get the next value and checks it. So if any of the numbers are odd, it will return false as soon as it processes the first odd number. But if we processed all the numbers and never found an odd number, it will execute line 12 and return true. This is correct because if we got to this point, the condition on line 10 was never true, so all the numbers are even. This is a common technique when you're trying to check if all the items in the list meet some condition. As soon as you find one that doesn't meet the condition, you can return false. And since the return statement exits the function, you know that if you complete the loop, that all the items did meet the condition. The key thing to realize is you're testing for the inverse of the condition to exit. So in this case, when we're trying to check if all of them are even, we check if we find an odd number and return false. Let's debug this and see how it works. With the first list 1, 2, 3, when we step over we see that x is 1 and it will return false. We'll resume and see the correct output for it. Now we're checking the list 2, 1, 3. We'll step over and x is 2. That number is even, so the if condition is false and it does not execute the code indented underneath the if statement. When we step over, it executes the loop with the next value. We can step over a few times and see it returns false since 1 is not even. We'll resume and see the correct output for it. Now we're checking the list 2, 4, 6, 8. As we step through the loop, the inverse condition will not be true for any of the numbers. So when the loop ends, we know that all the numbers are not odd, which means that they are even and we can return true. We'll resume and see the correct output for it. We've seen that we use the accumulator pattern over and over in different programs, so you want to understand how it works and how to apply it to new problems without needing to figure out the exact steps of the pattern from scratch each time. This pattern of checking if all the items in a sequence satisfy some condition is also fairly common. It's also easy to make a mistake, so I suggest you learn this pattern so you can apply it to new problems. There's a variation on this you could use to test if any numbers in the list meet a condition. We'll leave that one as an exercise. Learning these various techniques that are common and being able to look at a problem and quickly determine which technique you should use is a skill good developers have. It allows you to quickly solve problems correctly without needing to create the correct algorithm from scratch as you would the first time you encounter a problem. Once you know the pattern and can recognize it, you can quickly adapt it and apply it to new problems.